Okay, good morning. My name is Dean Plowman. I'm an instructor here at New England Tech, and today we're going to talk about user frames. This will be our fourth class, and we've talked about a lot of concepts before that, but I want to review some, and then we'll get into user frames. So here's the objectives. Review the Cartesian coordinate system, which again we've done. A discussion on user frames, and then focus in on a user frame. Procedure defining a user frame with the teach pendant, then setting a user frame with the robot, and then we're going to do a lab where we actually use the robot and go out and do it. Okay, so for the Cartesian coordinate system and the frames, the Cartesian coordinate system is used to describe the location and also the orientation of a position. And I'm going to go into each of those a little bit in a couple of slides forward, just exactly what the difference between location and orientation is. And a frame is an intersection of three planes at right angles to each other. And again, we'll talk about X, Y, Z. And then the point where all the three planes intersect is called the origin point, or 0, 0, 0, right? And what is the default frame in a robot, at least for our robot? Roll frame, right? And what's the advantage of the roll frame?
It's stationary.
And what's the disadvantage of a roll frame?
Stationary.
Yeah, okay, so, and we'll get into that. And these three planes can be represented as positive or negative numbers. And we can describe it two ways, two dimensions and three dimensions. Okay, so we've seen this before, probably in your math classes and in here. And this is a 2D Cartesian coordinate system. Okay, so here's our x-axis and our y-axis. And which way is positive and which way is negative?
Up and right.
Which way?
Up and right.
Positive, positive,
Yep.
negative, negative. And again, in this example, I can represent one point off of two axes. So here's a point here, 3, 5, right? Positive, so it's in this quadrant. And 3 would be the x point, and y would be the 5 point. Okay, we've seen this before. So now let's add another axis. Which one's that? X, Y, and again, 1, 2, 3. And we can also add another dimension. And again, I'm going to talk about the difference between location and orientation. But I can talk about roll, pitch, and yaw. And again, we'll see that in the next. So here are the frame types. Okay, we have the roll frame, which we talked about, can't be changed. Tool frames. What's TCP stand for?
Tool center point.
Tool center point, right? And what's the default tool center point?
End of the base plate.
Right at the base plate of the robot. And then user frames, which we're going to go into detail today and actually do the lab on. And then jog frames. Okay, so here's a picture of the teach pendant, and the coordinate systems defines how the robot will move, okay? And then also we're going to look at on here the 5 coordinate systems, right? Joint, world, tool, user, and jog. And these are frames, the bottom 4, right? And then what's joint?
Move every joint by itself.
Right. Okay, and that's a jogging movement, joint. What's the opposite of joint?
Linear.
Linear. Okay, good. So what you do is you can press the coordinate button and it toggles between all of the coordinates. So if I was just going to be doing some jogging, here were the keys that are important. And of course, on and off switch, of course, emergency on and off. The shift key and reset to jog, and then here's my coordinate button. Okay, pretty important button. And then here's my 12 keys used to jog. Manually move each axis of the robot, and I can adjust the speed. So the roll tool and use of jog frame are also considered coordinate systems. Along with joint, these are 5 ways of jogging the robot while in teach mode. Okay, and to toggle between the coordinate systems, you just hit that coordinate button, okay? And I'm going to show you in robot. So as you press coordinate, you will see the coordinate systems toggle in the upper right-hand corner. So if I bring up RoboGuide, and I look here, and I just go to coordinate. Can you see that here? Is that? Can you see those? So I'm just toggling with my different coordinate systems. So the roll frame, based on a Cartesian coordinate system, x, y, and z, and the major points, and I got a picture to show you this, the major points are J1, J2, and J3, and they move along the Cartesian axes, x, y, and z. Okay. Then the minor joints, J4, J5, J6, rotate around the Cartesian axes, and this would be J4, 5, and 6. And you can also consider it like yaw, pitch, and roll. Where have we seen yaw, pitch, and roll in our lives?
Airplanes.
Airplanes, right? In other words, that's how they navigate. It's similar. So the roll frame default of the robot, and it's located on the center line of the J1 axis and the height of the center line on the J2 axis. And I can show you when we do a demo. And the location of the origin never changes. Right? And jogging in the roll mode causes a linear, as opposed to a joint, movement with respect to the tool. Okay, so this is just showing you, what does UF 0 mean?
U-frame 0.
Right? And that's my roll frame. When it's 0, that's my roll frame. So if I make it 1, 2, 3, 4. So this is just showing you, if I move my tool from here to here, it's relative to the rolled frame. And we can also label the joints in a robot. And I got a picture to show you, J1 through J6. And the picture, I think, is a little bit better to show you this way. Okay. So here's J1, 2, 3. On which axis? Major. And that's what?
X, Y, and Z.
X, Y, and Z, the Cartesian, right? And then the minor axis, okay, J3, 4, 5, and 6, that's rotating around those three axes. And then one thing that will help us a lot is the right-hand rule of thumb, and we've talked about this before. Okay, so if I show this out here, my thumb is
Z.
positive going up. Okay, my pointer finger is X. Positive going this way. And then my second finger would be Y, going this way. Right? So that helps me understand where my location is relative to the roll frame. Right? So if I look at the robot and I look from behind the robot at the roll frame location, this determines my helps me remember which directions to move. Okay, so the user frame can be set up in any location with any orientation. We use it when the part is oriented differently from the roll frame and allows jogging in the X, Y, and Z, and the user frames can be used in the program. All the positions are recorded from a user frame, right? So when I define a user frame, everything recorded after that, right, would be relative to the user frame. And what's the advantage of that?
You can move it.
Right. So let's say my fixture moved. If I was in roll frame and my fixture moved, right, what would I have to do?
Reteach everything.
Right. But in the user frame, if my fixture happened to move, all I have to do is create a new user frame, and then every point after that would be relative to that. So this is just showing you the user frame, and what happens is that when I define a user frame, now the X, Y, and 0 are now at 0 relative to that user frame. Okay. So again, what this is showing me here is that when I'm in my user frame 1, and I move from here to here, that's relative to my user frame 1 position. Okay. And there's 3 ways to set up the user frame. The 3-point method, which is what we're going to do in the lab today. The 4-point method, which I'll discuss, and also the direct entry method, which I'll go over. Okay, 3-point method. Okay, it's 3 points. The first point is recording the origin for that user frame. How many user frames can I have, by the way? 9. Okay, I can define up to 9 user frames. Okay, then I would record the second one, and then I would record the third position. And I'm done. So I only need to record 3 positions to create a user frame. So in a typical fixture, I would record the first point, which would be my origin in the user frame. And then I would jog it to my second point and record that. And then finally my third point I would record. Okay? I'm done. That's the 3-point method. Okay, there's also the 4-point method, which we talked about. And that's used when you need to define a frame that has the origin other than the reference of the frame. And the first 3 points define the orientation of the frame. And the right-hand rule becomes that for that frame, and it's primarily using with remote TCPs. Okay, that's primarily when you use the 4-point method. So you record the first point, then the second point, then the third point, and then finally the 4th point, or the system origin point. That's the 4-point method. And then lastly, the direct entry method. The only thing needed to use the direct entry is the positional data of the origin point. Okay? And the robot can show these values on the position relative to the world if jogged to that point to teach the frame. Okay, so I can see the positional data, and that was what I would use for the direct entry method. And here's a picture of it. So again, setting up a user frame with direct entry, and I would just enter the information in those fields. And if you want to see or select which frame is active at the time, you use the shift coordinate key as opposed to just the coordinate key. Okay? Coordinate key just shows me my coordinate systems, and the shift coordinate key would show me which frame I'm actually in. And again, I'll show you how that works. And you scroll to the frame of interest, and then you can input the number. Okay. So I'm going to show you the 3-point method. Okay, so the first thing I want to do is go to the menu, and then down here, number 6, or the setup, and then frames. Okay, and that shows me. So here it shows me user frame 3-point method, which happens to be something I would do. But if I needed to change it, I could go to other. I could do my tool frame, my jog frame, my user frame. Okay, but here I happen to be here. So I could just scroll up and down, and for example, I would select user frame 3, and here I am. Okay, and then my method, here's the 3 I talked about, the 3-point, 4-point, and direct entry. We're going to do the 3-point today. So select the 3-point, and there's my 3 points, right? I would jog it to where I want the origin point, and then hit record. And then I would move it to my X direction point, and I would hit record. And then I would jog it to my Y direction point and hit record, and I'm done. Okay? this was just showing you how to do it, in case you needed it, because you'll get copies of these presentations. And so what I'm going to do is, I'm going to show you how to do it on the robot, the 3 points, and then we're going to go in the lab and do it. Okay? Okay, so now I'm going to demonstrate the 3-point method to define a user frame. And I'm going to use the CERT FANUC robot. All right, so what I want to do is jog to my first origin point. So what I'll do here is I have it in the user jog mode, and okay, so I'm at my origin point, and I'm going to record that, which will record the first of my origin point. The next I'm going to do is jog to my next point along the x-axis. Okay, and that's where I want to be there, and I hit record. That'll be my second point, and then I'm going to go along my y-axis. And that looks good there, and hit record, and now I'm done. It's that simple. I've recorded my 3 points for my 3-point method for my user frame.